Find the ratio V1 over V in this given voltage divider circuit. So here we need only one equation. When the resistors are connected in series this way, to find the potential, we can use potential divider method. So here what we do is we take the resistance ratio is equal to potential ratio. So here I have taken R1 is to R2 is the resistance ratio here in this circuit. So if I need to find V1, so what I have to do is I have to take the ratio value. So R1 plus R2 here and R1 into V. So here I get, when it is multiplied by total potential supply, I get V1. At the same manner, yes, I can find V2. So what I have to do is R2 divided by R1 plus R2 into V. So I get V2. Right. So we are going to apply this method in our question. Let's get into the question now. So here you can see current flows from, let's say this is point A, point B, point A to point B. So it comes down here. Now we cannot consider this part and this resistor are in series, because these two are not in series, because there's another current goes to this path as well. So what we have to do is, to apply potential divider method, we have to add all these resistors together, right? So let's apply them. So now you can see initially these two resistors are, yes, in series. So when resistors are in series, we can directly add them, right? It's 2R there, right? So now we have 2R here and R here. These two are parallel, right? Parallel resistors we add 1 over R1 plus 1 over R2 equals 1 over R method. Now the equation, let's apply these two then. 1 over R plus 1 over 2R. Let's take the resultant value R dash, then common denominator 2R, 1 plus 2 equals 1 over R dash. So you get, let's take the reciprocal value, R dash equals 2R over 3, right? That means now we have the resistance here. The total resistance is 2R over 3 and this resistance is, yeah, R, right? Let's write the values clearly then. We have R here and we have 2R over 3 here. Now we can apply potential divider method for this V. Right, let's take the ratio. R is to 2R over 3. Let's simplify it furthermore. So 3R is to 2R, then 3 is to 2. Right, so we have the ratios here. Let's apply the ratio values for these potentials. So let's take 3 plus 2, 5, 3, 2 over 5. Like we have the fractional value. So then we multiply it by supply voltage V, right? We get 3V over 5 for this R resistor potential, and we get 2V over 5 for this circuit, right? So now we have 2V over 5 for this circuit, point C and point D, right? So same potential we have for these two resistors as well. So now you can see these two resistors are in series. So we can apply resistor ratio method again. R1 is to R is to R, 1 is to 1 ratio. So then half and half, that means half of this value. So 2 over 5 into 1 over 2, you are getting 1 over 5V for each resistors. V over 5, V over 5. So you can see V1 is V over 5. So in the question they're asking V1 over V ratio. So we have V1. So divided by supply voltage. So we get 1 over 5 as our answer here. Second one is our answer. Right. Now we have done the question. So if you think this is valuable and helpful, you can share it with your friends, study together and win together.